LCD.
Exactly. The LCD, so what does this have to become?
5.
Yeah, 5 over 5. In fact, whatever number this was, if this was a 7, what would it make this?
7 over
7 over 7. And then what would I end up? 7 plus 3. So it's whatever number that is, times 1 to get the LCD, and then they add it because now they have LCD. So I'm allowed to put them together, right? That's why the shortcut works. 5 times 1, because it would be 5 times 1 to make 5/5, plus 3, because that would be the next step. So it's just a shortcut. The danger of shortcuts is they're easy, but you forget why they work. And then you forget how things work, and then that sucks. Right? So how, now that we got that little bit reminded.
Flip it.
Yeah, good. So 7 times 5/8.
35 over 8.
I like it. You can make 7 over 1 if you want to. Nothing cancels, right? So 35 over 8, which is 4.375.
4.3. And that's the exact.
You guys with me? So the estimate was about 4. It comes out to be 4.375.
So
Not bad.
do we have to do the estimate before we find out?
If they ask you to. Yeah, don't, please, your guy. Estimation is not get this answer and then go, oh, that's about 4. No. In the real world, what is estimation used for? So you don't have to do this, right? If you're on the work site and you're like, how much wood do we need, boss? The boss is not going to go, give me a minute. You know, the guy's on the phone. He's going to, I got to tell him how much freaking wood to bring. You're going to, we're going to need about, you got to know how to estimate. We need to do this and we need to do that. Let's get this much wood, a little extra just in case, and we'll make another little dog house somewhere. Who knows? Right, obviously I don't work in construction. But I guess, I mean, that's the point of estimation, is to not have to do that. Let's ask you to do both, just because. So if I had a problem like 2 and 2/7 plus 9 and 5/6, how would you estimate that? Do better than that. That's just a little bit over 2. And that's just a little bit under 10. That's close to 2. That's close to 10. 2 plus 10? 12. So my estimate for that would be 12. That's all there is to really to estimation, is you try to bring it to the closest number. There's a little bit more to it, but I'm not going to get that much more into it. That's all we need to know for right now.
So then to get the exact is where you multiply the.
So you get the exact is now by the book. Yep. You could do. You could make it into an improper fraction if you want to, and then you have to get LCD. Yeah.
Okay.
Yep.
Okay, let's say I did 11. Is that the wrong answer? It's just an estimation.
It's wrong to just cut this second half off.
Oh.
That's not really estimation. You want to kind of round better when you want to estimate, right? And in fact, if this was like the number of, I don't know, if I want the number of chairs for people to sit down, I'm always going to, I think 25 people, so let's get 30 chairs, just so we have enough, right? You always got to overdo it. Yeah.
So how do you know whether to go up or down? Like, you have 2 plus 10, and it's 2 plus 10.
Because that's closer to 2 than it is to 3, right?
What?
2 and 2/7, that's closer to 2, and that's closer to 10. And there's a little bit of, if I make that one go down, I should make that one go up. So overall, they add to be the same number. Does that make sense? That's the extra layer on top of estimation. You don't just change the numbers to the closest whole. You can actually be a little smart about, well, if I made one go up, and I'm adding, I want the other one to go down. So they add to be the same number, right? So for example, 8 plus 10 is 18. That's amazing, Jeff. 6. If I make 8 go down a couple, I better make 10 go where to still be 18? Up a little bit. There you go. So if I take one down, the other one's got to go up a little bit, and that takes me closer to right. That averages it out. That's as much as I want to talk about estimation. Estimation is not a huge part of this, but it does show up here. It's an excellent thing to know how to do when you got these freaking mixed numbers. Right? Yeah.
So just trying to figure out a way to think about it. So when the bottom is, when there's a big difference between the bottom and up, that means this is closer to the original number?
Yeah, so is that, you guys, when I talk about, for example, sevenths, 1/7 is obviously close to 0. Way closer to 0 than it is to 1. You with me? So if you actually graph, let me take some of this stuff away. This is getting a little crowded. So this is kind of important. So here's 1. 1, 2, 3, 4, 5, 6. Yay! All right, good. So 1/7 would be right there. That's obviously way closer to 0 than it is to 1. Where's the kind of point where you tilt over towards 1?
4/7.
4/7. At 3/7, you're still closer to 0 than you are to 1, but at 4/7, now you're closer to 1. Because what's half a 7? So right here would be the halfway point, right? So when you're rounding, if I said round 1 3/7 to the nearest whole number, how would you round that? 1 is closer to, I've gone off my scale. That's closer to 1 than it is to 2. Now if I said round 1 4/7 to the nearest whole number, that's 2, because now I've gone past the halfway mark, and now I'm up closer to 2. It's exactly the same idea with any kind of rounding. If it's 4 and down, you take it down. If it's 5 and up, you take it up. You with me? Because 5 is the halfway point, right? All right, cool. So that sort of ties into this estimation. You're right. That idea of when do I go up, when do I go down? It's the same idea as always. It's just weirder to think about halfway. Right? Whole numbers is always based on 5. That's easy. Fractions is based on whatever the hell the fraction happens to be. Right? So if I had tenths, of course, what would be the... 1/10 would go down to 0, but 2, 3, 4, 5/10 would round up to 1, right? 0 up to 4/10 would be 0, 5/10 up to 1 would be rounded up to 1. You guys with me? So it's kind of nice that it actually works exactly the same way as always. It's just the numbers we're looking at get more disgusting because it could be based off of 7, 10, whatever. Right, how much of this do you really need to know right now? Not a ton, because I'm not going to make estimation a huge part of this, but it is there and it's a good skill to have. In fact, if anybody is planning on taking Math 120 eventually, right, if I'm teaching that, I love teaching that class because we do a whole thing about estimation and we get a little bit deeper into it. And we also do like Egyptian hieroglyphic numbers and stuff, and Babylonian numbers and stuff. Some of you guys are like, yeah, and some of you guys are like, never. Never, Jeff. Never. Babylonian and Mayan and Chinese.
You can stop it.
It kicks ass. Let's focus on this right now. So, now I got my book. Since my real book is at home. Any questions from homework? Yeah.
I have questions on the practice.
Oh.
Are you planning on giving out the answers?
Yes, I am planning on giving out the answers.
Maybe I
I'm
should.
planning on it.
So I missed the last week. I didn't get a practice. Anyway, I can get one today.
Ran out.
Huh?
I ran out.
Oh,
So you can either come with me after class and I can print you out one. Yeah. Or you can email me and I can send you one.
So
Yeah.
the questions that I have that like I could not do were 10B and 10C. And I think it's because I'm confused on when you flip it.
Oh, and before you get too far along, the other thing I want to do tonight, I gave you back your the group work we did last time, and I love that you're actually like, there's nothing on this, but it's because I didn't have any time. I just put in the computer that you did it, so we're gonna go over those. I'll do them up on the board real quick, so you kind of have the how to do these. So let me do this problem, and then we'll do that, and then we'll just go back to the practice to see what questions we have. 10B, this one here.
Yep.
Now, the thing you always look for when you have fractions multiplying Or dividing, of course, because you just flip it and it becomes multiplication. What do you look for first?
Simplify.
Simplification. Good. You always look to reduce before your numbers get big and out of control. Does anything reduce? No. Nothing reduces up and down. Nothing reduces across. You can't reduce this way because, of course, they want to multiply. Reducing would make no sense. So since nothing reduces, I just multiply. 4 times 2? 9 times 5?
45.
Done. And I know that doesn't reduce because I know its parts didn't reduce. So, of course, those numbers can't possibly reduce. And then C.
So for 10B, you don't flip anything.
No, because it's already multiplication. 10C is the same problem, it looks like, but it's division. So the first step here is flip it. Always the second dude, right? Now what happens that didn't happen there? Yeah. And now, yeah. And if you want to, you can write that as
Mixed number.
1 and 1/9. Cool, right? Because 9 goes into 10 once with 1 left over the 9. So exactly the way you set it, since you first learned division, is exactly the way you set it up. All right, so let's do this. Let's look at, it was page 271, that group work we did last time. Anybody not get yours back? Anybody? Oh. Do you mean like correction? Alright, it might be part of what I left in my book. Anybody else? Cool. Everybody else all right? So again, if you got here after I said this, my book is at home. So it probably has, whoever didn't pick up the quiz last time, it's there. So if you come back tomorrow, if you're on campus tomorrow, Thursday, my office hours, I'll have stuff to get back. For the group work we did last time, it was number 2 and 3 to start off with. So 2, not too bad, hopefully. 2 ways you can look at this.
5/4 or 1.
Yeah, each part of this represents a fourth. So I got 1, 2, 3, 4, 5 4ths. Or you can write it as 1 and 1/4. I love it. Okay, so we've done several of those kind of problems, so hopefully you guys see how to look at that correctly. What about number 3? This one got a lot of people turned around, but this is the basic building block of a fraction. One of the most basic uses of a fraction is to represent a part out of a whole. So exactly the way it's written is exactly the way you write it. It's crazy. 73 out of 85. So that would be 73. Cool. That's exactly right. You guys, everybody with me?
Yeah.
Because I saw there were a few people that left it blank and a few people weren't sure what to do. It's almost too easy of a problem. And the 8 hours of sleep has got nothing to do with the math I need here. It's just setting up that ratio of people.
Just to confuse.
Sure. So right here. Let's see. And then we have number 5. That wasn't too bad, right? 5. So anytime you got a negative in a division problem, there's no other negative, the answer is going to be negative. So you basically, if you have a problem like 40 over -5, well, you know the answer is going to be negative because there's no negative to kill that guy, and 40 divided by 5 is 8, so it's -8. So So don't let those problems become difficult. That negative just kind of lives to the end, and then you can focus on the numbers. Now, if it was negative 40 over negative 5, of course, what happens?
They cancel.
The negatives go away, it becomes positive 8. I like it. So what about number 8?
Undefined.
Yeah, please. Number 7 is 0. Number 8, undefined. Because how do you check? For these problems I did, how do I check myself? Check myself. Yeah, negative 5 times negative 8 is 40, therefore it's true. Negative 5 times 8 is negative 40, therefore it's true. You with me? So if I thought 7 divided by 0 was 0, how do I check myself? 0 times 0, okay. I've got to be wrong. This is undefined because there is nothing you can fill in here that when you multiply by 0 gives you 7. That is why it's undefined. There's nothing defined to do that. So that's why we call it undefined. Alright, so that's number 8. What about number 11?
There's many ways to do that.
What's that?
Many ways to do that.
There's one answer, many ways to get there.
The 9 times 7 times 5 times 7.
Yeah, so 11. Where do you guys start?
5.
I started
Not a bad idea to start with 5 because it ends in 5. So I know 5 and it goes in 63 times 11. Right?
3 times 12.
Which one of those is prime?
5.
5. So then circle that bad boy. Right? 63 can go further.
7 9.
Good. So you can either 7 times 9, or you might even see
3 times
3 times 21. Right? But of course, both of these end up being the same thing.
3 times 3.
9 is 3 times 3, or if you had 21, it's 7 times 3. You end up with 2 3s and a 7. Either way you do it. So there's multiple ways to break it apart. Like I said last time, you're trying to take a car apart. You take the door off first, or the hood off first. Or, you're going to end up with the same splayed out parts at the end, right? But you can start taking it apart any way you want. So the answer, no matter which way you go, should be 5 times 7 times
9.
3 squared. Good. And that's, I like to call it the DNA of the number, right? You've broken it down to its parts that define what it is. If you multiply 5 by 7 by 3 squared, you can only get 315. That's the definition of 315. Is one way to kind of think of it. All right. Me too. Some of you guys look very interested. The rest of you are like, I'm about to finish. I understand. That's all right. I'm a math teacher. I'm used to it. Number 16. Oh, yeah. So one thing to realize is it's got a negative number. It's a negative in there. Right? There's no other negative, so at the end it's going to still be negative. And then you start attacking the 72 and the 80, and there's a...
9
Exactly. There's a straight way to get there, or I saw a few people doing stuff like divided by 3. You can't... Yeah, if you divide by...
2.
Yeah, 8's the quick way to get there. You could divide by 2, but then you can still divide by 2. I know, some of you, I love you. You're like, dude, why are you taking the long way? And then you can still divide by 2. But you don't stop too early. If you happen to pick a number that's smaller than you should have, you're going to have several steps. So you don't have to see the biggest number at the beginning. You just have to not stop too soon. Of course, don't go too far. But it should be pretty obvious when you get to the end. There's just nothing else that will go into both of them, right? So at the very beginning, of course, you could have just divided by what you guys were shouting out at me, like you're looking at a screen. Don't go in the room. Negative 9 over 10. Yeah. Right? Divide by 8. So it doesn't matter if you take several small steps or one big step, who cares? Right, you still get there. 19. I saw a lot of people not touching those Z's. Right? Didn't like the fact they were there. And I saw a lot of people not going far enough with the number. But first, let's take out the Z's first. How many z's up top?
Three.
3. How many z's on the bottom?
One.
How many cancel?
One.
1 z cancels, leaving with 2
Two on top.
on top, because that's where there were more. Z divided by z, z left, right? Z on top. Okay. And then what happens here with the number?
With 5.
Yes. Well, how did you get there though?
33 over 46.
Yeah, what definitely goes into both? 5. Divide by 5, divide by 5.
33.
Yeah, 33,
42.
42. And a lot of people got there and stopped. But 3 plus 3 is 6, which is divisible by 3. 4 plus 2 is 6, divisible by 3. So that means 3 definitely goes in. Maybe not 6. 6 might, but definitely 3 goes in still. Right? So if you divide both by 3, 11, 14. Yeah. And now it's very obvious that there's nothing else going to both. 11's prime. You guys with me? Yeah, you could have divided by 15 at the beginning. That's right.
Yeah, my Z's look like 2s. Can I change it? Can I make it a Y?
Yeah, that's fine.
That's okay.
Just at the end, put the Z back in. So it's not, especially with me and like T's, or me and S's. You do not want a variable S, because 5S is just 55, or it's a snake. I don't know what the hell it is. But yeah, anytime you get a problem with a letter that kind of doesn't look right, looks like a number maybe, change it in the middle. Because Z is just what's called a dummy variable. It's a placeholder, so who cares really what letter you use to work with? Just at the end, put the letter back in. I want to get you used to that now, because later in math, if it starts with a T, you better end with a T, because T might mean time. So if you give me a U or something, like, what the hell's U? Right? So it actually means a lot more later in math. So you could rewrite this problem as 165 y cubed over 210y. That's still not a good choice for me because that looks like 4 sometimes.
It helps if you put the line through it.
Yeah, the line through, I don't know, somewhere in history I learned to do that. And thank God for me, because that helps out a little bit.
Do 7s like that.
Huh?
People do 7s.
My 7s are the same. And then my 7s with my Z's, and I'm back at the beginning. Oh well. All right, so that's 19. Is everybody cool with that?
Yeah.
So a lot of you guys stopped at the 33 and the 42, but you gotta, I've given you some of the, I keep forgetting this. I said I'd do this last time, I forgot, but I might, if I can remember, I gotta make a handout to show you some of those rules. Like if they add up to multiple of 3, 3 goes in. If the last 2 digits are divisible by 4, 4 goes in. 5 is easy, everybody should know 5. It's 5 or 0 at the end, 5 goes in. Okay, cool, so forth, so forth. If it's an even number and the digits add up to a multiple of 3, 6 goes in. Because then 3 goes in and it's even, so 2 goes in, so 6 goes in.
That would be helpful.
Oh yeah, oh yeah. Well, that was too far, Jeff. All right. 32? So let's see, 32. What I'm seeing though is some people still have some trouble with sign numbers. So I'll get an answer like -4/5 here. Do you guys see where that would come from? Or I'll get 2/5, something like that. What's the mistake that they're making?
The sign.
What sign should the answer have?
Negative.
Because the bigger one's negative, right? And since they're opposite signs, you should actually subtract them, right? So 3 minus 1 is 2, but negative. And I can do all that because the bottoms start off the same already. I like it. So it really sucks if you got like it on the edge. You totally understand it, but then you're just not adding, subtracting correctly. That, I hate taking points off for that, but I'm going to. I don't hate it enough to stop. I don't want to. 33. So same numbers, now instead of subtracting a multiple, right?
3 over 4.
3 over. Now, why do you think I might get that sometimes?
Oh, yeah.
Because what really sucks about adding, subtracting versus multiplying, dividing is when you add, subtract, the bottom stays the same. Because you're collecting how many of those. When you multiply, you multiply. 1 times 3, 5 times 5. Right? So what about 38? Cool. Now the tops are like terms, but what's not in the right place here? What's not letting me add these? Yeah, the bottoms are not like. So who needs what?
3 needs 6.
3 needs to become 6.
By multiplying 2.
Yeah.
2.
So then you get
4x over 6.
5x. 9x over 6.
and then no matter what the problem was to begin with, when you get to the what you think is the end, take a second to see if it reduces. What goes into both?
3.
Yeah. Divide by 3, divide by 3. 3x over 2. What's up? So what about 44? We got 5 twelfths minus 1/9. So again, I showed you one method to do this that'll work all the time. If you don't like that method, any method I show you, if you don't like it, you can certainly use a different method. Right? As long as I can see what the hell you're doing. In fact, some of the methods I used, I learned from seeing my students work. So maybe there's a teacher that came up with something I'd never seen before, and then I make it my own. Right? So I like to steal from you guys. So, how would you approach doing this then? Yeah, 12. The biggest number these have in common is 3, because that's all 9's got. Right, it's 3. So this is 3 times 4, 3 times 3, and now I can see very easily who needs what.
9, you need 4.
Yeah. My LCD's got a 3 and a 4. It's got a 3 already, but it doesn't have a 4, so it needs a 4.
And then another 3.
And this guy, he's got 2 3s and a 4. He's only got 1 3. You got to give him another 3 to make them all happy, right? Just imagine these are little kids. He's got 5 pieces. Come here, all right. He's got 2 3. All right. Won't get back into my parenting style. It's probably questionable parenting tactics. But sticking with fractions, I can deal with that. What do we have here? 15 over 36 minus
4, 36.
kick ass. So now I'm allowed to put those together. 11 over 36. Does that reduce?
No.
11's prime, so no. Won't go anywhere. Cool. How are y'all feeling about that yet?
Do I have to show all that work on the test?
You gotta show me something. You don't have to show me how you get there, but at least show me what you're doing. From here to there. To there. I like it. Just don't go from that to that out of nowhere. That'll be like, oh, crap. Because there are calculators that have fraction buttons on them, right? And I want you going with your calculator to the next class. And I want your calculator going to the next class by itself. Because it'll pass and you won't. Oh yeah, the bonus was.
Page 317.
Oh, I think I got this one.
What was
Number
it?
122. Page 317.
Just find the area of the granite.
Oh yeah. All right. It's a slab of natural granite. Return the slab. It's purchased in a rectangle. A rectangle with length 5.5 feet. And width, I like the fact they made the width bigger. 7 4/11 feet is cut from it. Find the area of this rectangle. So of course the area in general of a rectangle is length times width. So I can just set up the problem, length 5.5, width 7 4/11. And now it's just a problem from like what we could have done in the earlier section, right? What do I have to do before I multiply?
That's his.
Yeah, so inside here I can make this 2 times 5 is 10 plus 1 is 11. And here 11 times 7 is 77. 81. You guys with me, everybody?
So 11.
Yeah, the beautiful thing is the 11s go away. So you can say this is 81 over 2. What's your units?
40 or 1 over feet. Square.
Square. All right, good. Square feet. This is area, right? Foot times foot is square feet. All right. Or you can write that, of course, I think someone's saying as 2 goes into 80. 40, and you got 1 left over. So either way. Cool. Slightly more correct to do this because it started with mixed numbers. I should end with a mixed number.
Is there a square mile?
Of course. Yes, a square anything. Right? If you set up, so if I had a big box, you can imagine, you can have land, a mile by a mile, piece of land. That would be 1 square mile. I love it. Cool. Square feet, square inches, square millimeters. Cool.
On the practice test, the number 5 feet, can we do it?
Oh, yeah, okay. 5B. What's the difference of a number and 7? Is that number decreased by 2? So, where's the math middle of this sentence? Where's the middle of the sentence according to math?
Is.
Yeah, is. That would be the equal sign, right? So for math, that kind of like breaks this sentence up into 2 parts. So right there is the equals. Now what's this side?
The answer.
That number decreased by 2. How do I write that?
2 minus x negative 2.
2x parentheses.
So I'm not saying twice anything on here, right? This is just a number decreased by 2.
X
No,
minus
less minus 2.
Yep. A number decreased by 2. So don't make anything more out of it. If I said you were making $10 an hour, now I've decreased it by $2. Now you're making $8. 10 minus 2. Some number decreased by 2. This is the side I thought would give us trouble. What am I actually doubling? Am I doubling a number or doubling 7? What am I doubling? Twice. What's it say? Twice the difference. So I can't double it until I know what the hell the difference is. I need to double the difference. It's exactly what it says here, right? So what difference am I taking? A number and 7. So how do I write that difference?
Minus 7.
And now that difference I want to double. Twice the difference. It doesn't say twice a number decreased by 7. It doesn't say that. It says twice the difference of a number and 7. I want to double the difference. Bam. So if I saw twice the sum of, I know I'm going to have 2 parentheses. Sum of something inside, right? And now the easy part should be solving it. Good. 2x minus 14.
Divide.
Yeah, actually I say on 5B you have to solve it.
Divide.
I 14.
Add.
Yeah, what's in the wrong place?
2.
14 or 2.
Yeah, you can say that 14's in the wrong place. That's cool. Or the 2, it doesn't matter which way you go, as long as you get your numbers together, your x's together.
2x equals x minus 12.
Negative 12.
Positive 12.
Which one's bigger?
Positive
14.
12.
Positive 12, right?
6.
So you can have negative.
Not 6. What's still in the wrong place?
X.
X. How do you get in the right place?
Subtract.
Subtract it.
1 x minus
X equals 12. Done. Don't divide too early. You almost always divide last. So if you're dividing before you are done, if you're dividing in the middle of the problem, you are probably doing something wrong. There are very few situations where that actually is better to do. I'll show you one of them since I just said something about it. If I had an equation that looked like this, almost the same as that, but it looked like, let's say, this. I can divide right now and actually make it a lot quicker. All right, this is 2 times this is 14. Can't I divide by 2? That's the one time that you can divide early and it won't mess you up. Now, do you have to divide early? No. Hell no. I can still take the 2 through and do it like we just did that one. But this is the one place where dividing early makes sense, because it'll actually go into everything nice. Here, I don't want to divide that one. So x over 2 minus 2 over 2. I don't want all that crap. 2 over 2 is nice, but still, x over 2 doesn't look too good. You guys semi with me? So a lot of times I'll have somebody doing something like 8x equals x plus 16, and they start dividing by 8. Can anybody tell me what I've done wrong? Yeah, how did he escape? If I divide one side by 8, I better divide the other side by, and I don't want to deal with that. That looks disgusting. This is one big reason why you don't divide too early. I should have subtracted the x before I divide stuff, right? Okay. Maybe. Okay. So let me do this. I think, make sure as I give these out that you have 2 sides. Mine, at the end, we start back at the beginning. So what I did is I took the practice list I gave you was one side and just blew it up so then I could have space to work. I want to be nice for myself and then you, I guess.
Sorry, number 1, you didn't show your work.
Today's a review day, yeah. So we're not doing anything new. Make sure you got 2 sides. Yep. Cool. Thanks.
Look at it.
Good. I like that. So I would highly recommend you follow Drew's examples. And if you have not tried that practice that's out yet, don't even look at the answers. So I really just gave it to you in case you've done some of the problems already.
That's exactly what it says not to do.
Sorry.
That's what I would do.
I took a picture of that picture.
Yeah.
Some of those, the visibility tests that we're talking about is on page 222 and 223.
Here we go. Oh yeah, this is even. Some of the digits is divisible by 3. Then the whole thing is divisible by 3.
And 223.
0 is 5. So this guy. Yeah, the last 2 digits are divisible by 4. It's divisible by 4. If it's even and adds to 3, so if it's divisible by 2 and 3, it's divisible by 6. This one, less and less people know. This used to be the one that everybody knew. If the number's at 9, then 9 goes in. And that's when you get all the way down. So, see here, I would even go one step further. 5238 is 5 plus 2 plus 3 plus 8 is 18. 1 plus 8? 9. So if you take it all the way down, then it comes out to be 9. 9 goes into the whole damn thing, whatever it started off as. Alright, that's pretty good. I like that. You know, I added that. So 222, 223. Cool. That'll save me some time. Yeah.
That one question we had, like the first question we had, number 2, we had two fours, right? You said it was 5 4s. Why couldn't it be 5 8s?
Oh, I see what you mean. What page is this?
The first, yeah,
Here?
it's actually 8 seconds.
So the problem is,
Oh, I see.
it's got to agree. So 2 problems. The minute I set up what a whole thing is, and then I start cutting it, I set up what my parts are. So a whole thing is definitely a circle. And I've cut a whole circle into 4 parts. Therefore, each one of these is 1/4. Right? So whenever I have a picture that's not connected, I have a whole thing and a whole thing and a whole thing, right? And it's been cut up. Then that's got to be a mixed number or an improper fraction, right? So if I had a picture,
If it's just 1, like the first one, it's just 3 7. It's not.
exactly, because it's connected. Oh, that, yeah, I hate when they do that.
Yeah, that's what
The problem there is they didn't cut this up in any parts, right? But I agree with you, actually. I really don't like it when they do that. Because I would look at that and say, that's 3. What do you want from me? So normally, if it's connected, like we did the ice cube tray,
right.
then it can say, what fractional part of the ice cube tray is full. Yeah.
But if there's 2 of those,
Yeah, if
one in the
there's,
whole,
and there's 2 of these. So I've already set up that one compartment represents how much of a whole thing?
so that'd be
1/8,
3 8.
right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 eighths, or of course 1 and 3 eighths. And of course we know that those are the same. Cool. So anything we talk about like this has to make physical sense. Believe it or not, everything we do with these numbers have to make physical sense. There's always got to be some physical example. Yeah.
Okay, so last week we talked about borrowing and the fractions, so is that going to be the test?
Oh yeah.
Is that going to be on the test?
Oh yeah. So I think, yeah. On the practice test I didn't put in, but we're definitely going to have some. We're definitely going to have some mixed number problems beyond just stuff like this. And I'm going to ask you at least one problem. It's going to say to do it the borrow method, just to make sure everybody could, if they really had to, which you will. So if I ask you to do this problem here, using the, now first off, my first question would be really, why the hell do I have to do any borrowing? Bless you. And actually, there's one thing I forgot. There's somebody who pointed out, why can't this just be -6/11? And it can be, and I will show you why, and I will probably freak a lot of you out, but I want to be real careful. There's a lot of cool stuff you could do. There's a lot of shortcuts you could make, as long as you fully understand why it works, and when it's legal to do it. Right? So I will show you, since that came up last time, and I forgot, I said I would show you, so I'll show you this problem. So first let's do it the straight up by the book method of borrowing. What's really nice about the way it's set up already?
They're the same denominator?
Yeah, they already have a like denominator. If they didn't, I would just do that first step. And then I would do what I'm about to do. So if I borrow from this guy here, then what can I add on to this part? If I borrow 1, what is 1 also known as? 11 over 11. So if I add that 1 that I took onto this becomes
13.
13 11s. And some of you guys might remember the shortcut was just 2 plus 11 is 13. That's what the top's going to be. Now, I see a lot of you guys with very pained expressions. But if it makes sense to borrow with any number, then why should fractions be left out? They shouldn't be. They cannot be. It would be impossible for them to left out. If there's an idea of borrowing for subtraction, there's an idea of borrowing for subtraction, period. I don't care what kind of number you got. So the idea is the same. So very often in mathematics we have a process, and the process doesn't give a crap what's in it. It just is the process I use. So what process do we use when I've got like 82 minus 19? Borrow. And a lot of us do it without even really understanding. Nobody's ever really told us necessarily why the hell it works. Or maybe they did it a long time ago, we forgot. But when I do this, what am I actually taking away?
10.
10, good, this is 80. So when I make that 70, I've just taken 10. So of course if I put the 10 on the 2, it's now 12. So I'm doing the same damn thing. If I take a whole 1 away from 8, and I add that 1, which I'm going to make look like 11 11s, that's still 1. But just to make it LCD, it's going to become 13 11s, right? That's all it is. Same exact thing, believe it or not. Just looks worse here, but... And then when you do this, 7 minus 3?
4.
13 minus 8?
5.
5 11, stuff. Real quick, and please, dear God, I sometimes go too far, but I promise you I'd show you this.
And this is going to be on the test?
This kind of problem will be on the test, yes. Let me show you something, just to hopefully...
Confuse us.
Yes! That is my hope. And actually, let me start with this. What was the one you just had up here? This. Guys, I just had that problem up here, right? Just to show a little something, right? So we took a 7, made 12, so it should be 63. Is that cool?
Yes.
All right, now, let's say I was not really paying much attention, and I just started doing it. 2 minus 9.
7.
Negative 7. Right? And 80 minus 10, basically. 70. What's 70 minus 7? 63, holy shit! Right? I mean, you guys kind of with me? Looks really weird, but it's because 2 minus 9 leaves you in the hole. 80 minus 10 is actually more than you should have been able to do. So together, they come out to the right answer. This tells you how much down you are. This tells you where you really shouldn't be. When you put those together, you get to the right place.
Where'd you get 80?
Because that's 80. Isn't it?
80 minus 10 is 70, yeah.
Let me write this a little different way. 12 minus 9 is 3. 70 minus 10 is 60. 60 plus 3 is 63. I mean, that is what we are actually doing. We just don't write all that shit out, do we? But that is what we are really doing. So that's why when you try to do something creative, which completely exists in math, people think that the word creativity and math, they don't go together. That's insane. They have to go together. You really have to understand why the non-creative shit works. What are you really doing when you do this? If you don't really understand it, then you're never going to be able to come up with something more creative and quicker and a different way to do something, right? So real quick, to do this one like we just did that one, and again, you never ever, please dear God, never have to do this. I am not saying you ever have to do this. In fact, put your pencils down. We do the same thing. 8 minus 3? 5. 2 minus 8? Yeah, minus 6 11s. So now I got to do 5 minus 6 11s. See, now now you can see why this doesn't work all that good for, well, unless you...
Maybe 5 over 1?
Yeah, so if you did that, 55 over 11 minus 6 over 11 is...
49.
And what's this? 11 times 4 is...
44.
Plus 5 is 49 11s, right?
So you can't do either one? No.
I highly recommend you don't do this. Why do that to yourself?
The only question was 13. How'd you do 13?
13.
on top of the two.
Oh, here.
That's what I'm asking for.
That's considered.
I got you. But just look at that problem. Let me take that away real quick.
Yeah.
Just look at this one a lot.
Because if it
This
was
is
12,
eight.
whatever number's on the bottom is gonna be.
Hold on, but why is it work?
Yeah.
So that's another way to write that. It's the same thing, right? You with me? Another way to write that is 7 plus 1 plus 2 11s. It's the same damn thing, right? It's just Jeff being bored writing stuff out. But then 7 plus, well, what's 1 plus 2 11s?
11 plus 2.
So many things.
So 7 and 13 11ths is the same thing as 8 and 2 11. Because think about it. 7 and 11 11ths would be 8. Why would I ever write 7, 11, and 11? So how much over 8 is this? 2 11ths. That's why these are the same stupid thing, right? Okay, maybe. But that's exactly why this shortcut works. Take 1 away. Since it's going to be 1, the top will be whatever the bottom is. And that's what you add to 2. So the shortcut is just 11 plus 2 is 13. Let's do one more.
On the test, do you want us to like write our own answer, or you just want us to show that?
How do you mean? I'm sorry.
To explain the borrowing concept.
I want to see the borrowing happen. The same way I'd want to see it happen on a normal subtraction problem. Right? Cool. So another example. What do you got, John?
So you got
3 and... Let's make it... There you go.
So you borrow.
So if I borrow 1 from this,
And then
I can add 1 to this, but it's got to look like what?
21.
21 over 21, so 21 plus 8? 29.
So just add.
top part. It's the same number.
Exactly. And the reason, again, the reason the shortcut works, the reason the short, guys, why do I like the fact you're all talking about math, it's fine, but I don't want to shout over you guys. Whatever this bottom is exactly what this is going to become. And then that's going to add to that. So why do all that crap? Just say 21 plus 8 is 29. Because I know what's going to happen,
So
right?
you just add the 8 plus 21?
The bottom and the top.
That's 50.
It's silly. So whenever you add 1 plus a fraction, 14 plus 11,
95.
whenever you subtract a fraction from 1, here's a cool thing. 14 minus 11, 14 minus 11. Those are shortcuts. And again, do you ever have to really understand a shortcut? No, but if you don't understand it, never use it. Right? You can do that the long way. And the long way is not that long, because this would be 1 over 1. You can make that 14 over 14. There's 3 14ths, right? But that's why the shortcut works. The top would become whatever that bottom is. So the bottom is actually telling you what the problem would be. 14 minus 11, 3 14ths. Okay.
So that's the answer, 3 14?
Yeah. But again, I really try to make it clear when I'm showing you something you don't have to know how to do. Right? Versus the main idea of how to do something. So if you don't understand the shortcuts I show, they are just shortcuts. They don't mean anything. If you happen to see them, great. If you don't, you always have the other way to do it. Right? The more comfortable you become, the more shortcuts you'll understand, and maybe some shortcuts you'll create on your own. Okay.
I have a question.
Oh, I didn't finish this out. 11 minus 3? 8. 8?
13.
And 13 over 21, is that reduced?
2.
No, 13 is prime, so that's the end.
I thought that part was part of this problem. I was like, where are you going?
Oh, yeah, I see what you mean.
Yeah, I was like, okay.
I do that a lot. So just,
So I think you had a little too much caffeine before it's not.
no. Actually, no, definitely not. All right. So anything else from homework or practice?
The reverse part, the addition.
Just again.
The addition.
So in addition, what's really funny is you end up with, your answer can end up looking like this. So it's kind of like reverse borrowing in that case. So an example would be if I had 14 and What you got, Jeff? 7/9 plus 3 and
What you got, Jeff?
That's good. It's 3 and 11/18. So what do I have to be careful of first?
Denominator.
Yeah. So who's got to change?
9.
Good. Do what to him?
8, 2.
So it's 14 and
18.
14/18 plus 3 and 11/18 is 17 and. Now that's bad. If you stop there on the test, I'm going to take some points off because that's not allowed. A mixed number cannot also have improper in it. It's either one or the other. So you have to do the opposite of borrow. And again, you just think about how much over a full thing do I have here? How much over a full thing do I have here? I'm 7 over a full thing, right? So if I take one full thing out and put it here, that's 18. And I've still got 7 left. Because again, if you really analyze it, 17 plus 25 over 18, which is 17 plus 18/18 plus 7/18. Holy shit. If you break it all the way down, 25 is 18 and 7. Why did I pick 18? Because it's 18/18. So that would be a full 1. That's the one that comes on this dude. 7 left over. Now how could you eliminate all that problem from the very beginning? I could have just made improper fractions, but then you end up normally with very large numbers to work with. Yeah, so it's a trade-off. Can you handle that later, or do you want to deal with large numbers? It's a complete trade-off. Yeah, you still have to do at least kind of 9. I could first make it into improper, and then I could change the, or I could make it right here. I can change it to improper, right? You can see it's going to be 18 times 14 plus 14. You know, yeah, it's a little bit big. So 266.
The final answer was 18 and 17.
Okay, cool. So you want to try this one the other way out? You want to try this one if it was to make it improper? Like, you guys are like, any question you ask involving math right now, the answer will be no. Let's actually take it from where we got to. So we have 14 and 14/18 plus 3 and 11/18. So me, is that 266? I think I did it in my head real quick. 18 times 14 plus 14?
I'll get my calculator out.
14.
I think it's 266.
266.
Yeah. So 266 over 18 plus 65. Yeah. You guys with me?
Yeah.
Numbers are just getting big. The process doesn't care. So still multiply, add. So 266 plus 65.
331.
Yeah, 331. And if I change that back, since I started with mixed numbers, I should end with mixed numbers. 18 goes into 331.
18.38.
No. So 18, and the way to do it in the calculator is, what's 18 times 18?
324.
324, and how much extra do you need to get up to 331? 7. Which is what we got there, thank God.
Why
Right?
did you end up with that at this number?
Where at?
The first way you did it. How did you come up with 18 over 17?
Because we came up with this, right? Is that cool? Just by adding them straight up. And this was over. This was actually exactly 7 over a full 1. So if I take a full 1 away, if I take 18/18 away from that and put it back here, take 1 away, the opposite of borrowing. Give it back to me, right? Time to pay back. So you take 1 away from that dude, you leave him with 7. Because he had 7 over 18/18, right? He had 7 more than 18/18. Does all that make sense the way I'm saying that?
Yeah.
It's a really good way to look at it because we often think of this as the remainder. So 18 goes into 25 once, There's 7 left. That's another way to work. Maybe. Anything else from homework or?
I have one from 4.5. Question 75. On page 267. Sorry.
75? Oh. So this is a good example of the process doesn't care about what numbers you're using. So they give you 2y plus x, and they tell you at the beginning x is 1/3, y is 3/4. So I know how this process works. I just plug them in. Now the mistake I see all the time is somebody will write this. Now, why is that wrong? X is 1/3, y is 3/4. What the hell's wrong with you, Jeff? What's wrong with that?
Common denominator.
No. What's wrong with it? What operation is this?
Multiplication.
Am I multiplying? No. 2 and 3/4 is 2 plus 3/4, right? So that's why when you plug something in, you should do it in parentheses, so you still maintain the operation. So the biggest, it's just like if I said 7x plus 2, and x is 5, this is not 75 plus 2. That's craziness. That's not 70 plus 5, that's 7 times 5. You with me? We already know that this number does not mean 35, that's 75. So if I want to multiply, I better show myself I'm going to multiply. This is the same thing as 75 versus 7 times 5. That's the exact same idea. So it might be one mistake that would happen on that problem. Now, how do I keep going with this thing? Okay, that's one way to go. You could also... So I get 3 halves plus 1/3. And the next thing I see a lot of is people start to cancel the 3 because they get a little too optimistic. But why won't the 3 cancel, of course?
It's not multiplication.
Because it's adding, which is not cancel division. Yeah, I have to be multiplying to have that happen. So now I need to get
6.
LCD, 6. This guy needs a
3.
Yeah, he needs a 3. He needs a 2. 9, 6 plus 2, 6. 11, 6. Good. Or
1, 5, 6.
get 6 goes in 11 once with 5 left over. Like it. Now, real quick, something I was thinking about earlier that just came back is if I had 15 gallons filled my tank and I used 3/4 of a gallon, somebody have a quick way out? I shouldn't need to do a lot of work for this. I really shouldn't. Is it all the way down to 14? If I had 15 and I used 3/4, am I all the way down to 14? No, I didn't use a whole gallon, right? How much before a whole gallon? How much less than a whole gallon have I used? A quarter. I haven't used a whole gallon. I've used a quarter less. So it doesn't go all the way down to 14. It goes down to 14 and that extra quarter, right? So it's sort of the same thing as doing 100 minus 82. You really shouldn't have to set it up to borrow. You just think, how far away is 82 from 100? It's 18 away. So that's 18. So how far away is 3/4 from 15? It's actually 14 and a quarter away. Right? Or 14 and a quarter is 3/4 away from 15. Do you have to do it that way? No. But this is where you want to kind of head towards. So you don't have to spend a lot of time setting a problem up. But right now, if you're not able to look at that and just tell what it is, you can still always just get LCD. Right? So this will be
4.
good. 60. 64 minus 3/4 is 57/4. 4 goes into 57. 14 times with 1 left over. So there's that 14 and a fourth we got earlier, right? So there's the process that works by the book, and then there's always other ways to look at it. And those other ways to look at it very often are quicker. But it all depends on how comfortable you are with how things work.
Can you have 87 in the same section?
Oh, yeah, the washer one? That one? Yeah. So we did that one. I can't remember if it was last time or before.
Yeah.
But we did that one, the whole thing was an inch. And then each of these were 3/16.
316 plus 316.
Oops. So if the whole thing is an inch, and they want to know what this middle part is. So I kind of showed you how algebra actually helps us. I don't know what the middle part is, so I call it x. I don't know what it is, so I'm going to call it x. So then what's got to be true about 3/16 plus x plus 3/16?
16 over 16.
What's got to be true about that? It has to equal 1. Because the whole thing across is 1. You with me? And now, I don't care the fact that there's fractions in here, really. And actually, this is not the only way to do this problem, obviously. But how do I solve for x? I do the same thing I always do. I get my like terms together. What can I do with 6/16?
Minus subtract.
But even better, by itself, what can I do with just 6/16? Reduce it. You always reduce them. Good. And then the last step, the only thing that's out of place, 3 over 8 is out of place, right? That's why x is not by itself, so subtract 3/8. So, x equals 1 minus 3/8. Maybe you guys can get that without setting it all up.
8 over
Minus 2 over
5 over
5 over 8. Yeah, be careful, didn't have an LCD yet. But 1 minus 3/8 must be, if I do 1 minus 3/8, the answer should be what I add to 3/8 to get 1. Let me say that again. If I take 1 minus 3/8, the answer should be what I would add to 3/8 to get 1, right? Why is 10 minus 2 8? Because 8 plus 2 is 10. So 1 minus 3/8, what do I add to 3/8 to get 1?
3/8.
3/8 plus 3/8 is 6/8. It's not a whole thing, right?
11 things.
What over 8 would be a whole thing? 8 over 8. So what's missing here then? How much to make it 8 over 8? 5. So that's why the answer must be 5/8. Now again, you can make the 1 8 over 8. 8 minus 3 is 5/8, right? But again, I'm trying to show you a different way to kind of look at the same problem.
I don't know if this will work for all of them, but for this one over here, I did 15 times 4 minus 3, which was 57 over the denominator.
Yeah, sure. Just because the bottom is 1. So the bottom needs exactly that to make like denominators. If the bottom was not 1, that would not work. Does that make sense? It's just because you did exactly what we did, just a little bit more directly. But if this would have been a 2, you would have been wrong.
I did it because I know if it's 15, it's 15 fours, right? That 15 is 15 of those of the denominator, right?
Well,
15 fours.
that 15 is how you're really thinking about how many fourths would 15 be? Like 1 is 4 fourths, 2 is 8 fourths. So 15 must be 15 times 4 fourths, 60 fourths. Exactly, yeah. So again, you have it's not, how do I say it? You have a unique way of looking at it, which actually works perfectly. And there's nothing wrong with it. There's not a damn thing wrong. Everyone has a unique way of looking at things, right? But it works for you, so go for it. Go with it, because it's exactly right. The way you're thinking is right. It's just, for me personally, it's a little weird, just for me. Everybody's unique. But it works for you, so what the hell? Yeah.
So there you used algebra, but I just did it.
Oh, yeah.
1 inch minus.
Yeah, this is just one way to do it.
Yeah.
You can do 1 for the whole thing minus 3/16 minus 3/16 to get to what's left in the middle. You don't need algebra.
They're the same.
Yeah, I like it. You don't need algebra for that part. Don't get too excited. My teacher said we don't need algebra. All right. Yeah.
There's
So,
one,
I'm sorry, real quick. Were you okay back there? You had your hand up earlier? You're good? All right.
in section 4.3, there's one question.
4.3, what page? Oh.
Page 241,
So which one?
85. I did do it, but I'm not sure.
All right, good. Yeah. So in the U.S., 4/25 of college freshmen major in business. So let's think about what that really means. If there were just 25 college freshmen in the United States, how many freshmen would there be majoring in business? 4, because 4 for every 25. If there were 50 freshmen, there would be 8. It's just kind of building the fraction up. So another way to look at this is it's 4/25 of however many.
800.
Yeah, exactly. Because if there were 25, the 25s would cancel be 4. If there were 50, 50 divided by 25 is 2 times 4 is 8. So that's how you use fractions. And we all already know this. How do I cut something in half? If I have 8, cut it in half. You get,
Multiplied by half.
cut 8 in half. You get
4.
4, thank you. Because it's multiplied, 1/2 of 8. So 4/25 of. So that's the key thing. This is what's weird to me is fewer and fewer people know this, and I think they're not teaching in high school as much as they used to. The word of, when you're dealing with fractions and percentages, means multiply. Right? 4/25 of the number of freshmen. Okay, well now, like you said, how many freshmen are there? 800. So 4/25 of times 800. So I'm going to be careful. When I'm dealing with fractional parts of something or percentages of something, of means multiply. It used to be just known, and now I'm noticing fewer and fewer people realize it. So how the hell do you do this?
25. It goes 32 times. Or
Yeah, 25 goes into 800
it's 5.
some number of times.
32.
32.
32.
Yeah, because 25 goes into 100 how many times?
4.
4. So for every 100 is 4. So there's 800, that's 800. So that's 8 times 4 is 32. Holy shit. All right, so 25 goes to 80,
32 times.
32. 32 times 4,
128.
128.
Freshman.
Business majors. Freshman business. Freshman business major. Cool. I used to do stuff like that. At the college I used to work at on the East Coast, I placed every freshman into their first math course. I was the placement director for mathematics. So I would look at all their SAT scores, their GPAs, the highest math class they took, and I would do math to it, and I would get a number. And the number I could predict what course they would probably place into. And then I can call the math department and say, you guys need to have this many sections of this, and so we could plan, because otherwise you just set something up like, shit, we were wrong, we better close some of these, that would suck. We want to have the schedule set ahead of time. So this kind of thing actually does happen. You try to get a feel for things, you say, yeah, we predict this is going to happen, so we got to be ready for that situation, yeah. So anything else from homework or... the practice test or Yes.
Random question. Do they normally offer math classes in the summer?
Well, now that we have summer back, yeah. I don't know if you guys were around back the last 2 summers. This past summer was the first time we had summer. The last 2 summers before that, we didn't have summer courses at all, basically. We might got a few, but I don't know what they did to do that. But now summer's back. And in fact, intersession's back, if you want to be crazy and take. I taught a 3-week statistics course. Talk about insane. I told them all the first day, you're all crazy, but let's do this. So I'm not sure yet what we're going to offer over intersession, but I know it's back. So the intersession's from January 2nd or something up through 3 weeks after that. Yeah, that's intersession.
I took a summer course, man, it was sad.
And that was 6 weeks, right? Or 4? Was it 6?
Yeah.
So imagine 3. Double the madness. Half the time, double the madness.
Right.
You guys don't have to sit there and stare at me, by the way. I mean, if you're ready for the test, you don't have to sit there and wait. Yeah, you could have been done a long time ago. Review day, you don't have to stick around until you get what you need.